Hello everyone, my name is Gabriel Anderson, and it is my pleasure to be able to present our research titled Using Machine Learning to Predict Instagram Engagement Rate. This work was conducted together with Albertus Santoso and Rafael Anderson at Nusantara University, and we are delighted to be able to present this research at the 12th International Conference for Smart Society. So here is an outline of today's presentation. First, I will begin with an introduction of our research, followed by the problem and objectives. Then I will walk through with our methodology, which consists of data collection, dataset preprocessing, and machine learning models that we employ. Then I will present the results of our research, as well as several key insights. And finally, I will conclude the presentation with the implications of this study and directions for our future work. So, in the current digital era, social media has undeniably become a significant part of most people's life. As of 2020, there were over 3.6 billion active social media users worldwide, which is expected to keep growing annually. And Instagram in particular has over 500 million daily users with over 1 billion users in total. And within this ecosystem, influencers plays a central role in digital marketing. The effectiveness of influencers is often measured by their engagement rate, which reflects to how the audience interacts with the content of the influencers. This metric is crucial for brands as it determines whether collaborations with the influencers actually drive awareness as well as exposure for the brands. So here are our problems. Despite its importance, accurately measuring and predicting engagement rate has become increasingly difficult. And Instagram frequently changes its algorithm, which reduces organic visibility for influencers, which results in accounts with many followers often struggle to maintain a consistent amount of engagement rate. And for brands, this creates a challenge, which is to distinguish genuine influence from inflated numbers. And traditional methods, which mainly relies on the number of followers and likes, provides limited insights, which may lead to inefficiency with wasted investments in influencer campaigns. So we categorize these challenges into four issues: limited visibility, questionable authenticity, analytical blindness, and inefficiency in marketing outcomes. So our study was made with three objectives in mind. First of all, to identify the key influencing factors and to predict the Instagram engagement rate. Secondly, to compare the 5 different machine learning models to predict the Instagram engagement rate. And thirdly, to provide actionable insights that can support brands as well as influencers in optimizing their marketing strategies in a more data-driven way. So here are our methodology. It consists of four main stages. We start by data collection, which we got from multiple sources. Then we conducted pre-processing, including cleaning and feature engineering. Then we applied our 5 machine learning models to predict the engagement rate. And finally, we evaluate the models using standard regression metrics to determine which approach was the most effective. And here are our dataset. It has 11 features, which is the username, followers, average likes, average comments, average engagement rate in the last 60 days, posting frequency in the last 60 days, post image type, post video type, post carousel type, and average hashtags per post in the last 60 days. So our dataset has two primary sources. The first source is InstaLoader, which is a Python library for scraping Instagram data. We got 743 accounts from InstaLoader, and the second source was from Kaggle dataset, which contains the top 200 most followed Instagram accounts. And by combining this dataset, we formed a final dataset with 943 accounts, covering both global and Indonesian profiles, as well as different influencer sizes from nano, micro, macro, and mega. And to prepare our dataset for modeling, we took several pre-processing steps. Firstly, we cleaned each dataset separately by removing irrelevant columns and ensuring consistency. Next, we add the last 60 days features to the Kaggle dataset, as the initial Kaggle dataset doesn't have the 60-day features. And then we merge our datasets and we remove outliers using the z-score method in our merged datasets. And we use pandas and numpy for data manipulation, and seaborn and matplotlib for data visualization. So we evaluated 5 supervised machine learning models: gradient boosting regressor, XGBoost, random forest, catboost, and k-nearest neighbors. These models were chosen because of their each complementary strengths. Ensemble methods such as gradient boosting and random forest were chosen because of their well-known ability to capture complex patterns, while k-nearest neighbors provides a useful baseline for comparison with other models. And to measure the performance of our models, we employed 3 different evaluation metrics. First of all, mean squared error, which penalizes large errors by squaring them. Secondly, root mean squared error, which is the square root of MSE and represents the typical prediction error in the same units as engagement. And thirdly, the R-squared score, which measures how much the variance in engagement is explained by the model. And using these 3 evaluation metrics allows us to assess both accuracy and explanatory power. So this is our result of our machine learning models. XGBoost clearly outperformed the other models with an R-squared score of 0.94 and an RMSE of 1.26, which indicates high predictive accuracy. And gradient boosting and catboost models also performed well with an R-squared score of over 0.90. And k-nearest neighbors performed moderately well with an R-squared score of 0.82. But random forest performs the worst compared to the other models with an R-squared score of 0.73. And overall, this result highlights the advantage of gradient boosting models for this problem, as XGBoost, catboost, and gradient boosting performed well compared to the other models. And beyond our model results, we have our key insights. Firstly, the post type content matters, as carousel and video post type consistently achieve a higher amount of engagement rate compared to static images. And secondly, hashtags have minimal to no impact in the engagement rate, which suggests that quality content is more important than keyword tagging. Thirdly, smaller influencer accounts such as nano and micro influencers tend to have a higher engagement rate compared to bigger influencer accounts such as macro and mega accounts. And finally, the engagement rate over the past 60 days strongly correlates with the average engagement, which suggests that it is a strong valuable predictor. And this is the graph of our key insights. As you can see, there is a significant gap between the post type from videos and carousel with images. And in the correlation heat map in the matrix, as you can see, the average engagement rate in the last 60 days has a strong correlation with the average engagement rate, which indicates that it can be used to predict the long-term engagement rate. And the most surprising one was the result of the hashtags. Since it's contrary to common beliefs, the number of hashtags had minimal impact on the engagement rate. And this suggests that the posting frequency, content quality, and audience relevance are way more important compared to the hashtag strategies. And to conclude our presentation, our machine learning models can predict the Instagram engagement rate effectively, and gradient boosting models performed way better, particularly XGBoost, which is the best performing model. And from a practical standpoint, brands should not focus solely on influencers with a large number of followers, as smaller influencers tend to provide a better engagement rate at a lower cost. And furthermore, the content format and recent posting matter more than the hashtag usage. And for our future work, we aim to expand this research to more social media platforms such as TikTok and X. And we plan to expand our dataset size as we currently only have 922 accounts. And we also want to be able to predict the real-time engagement as well as use better scraping tools. And we plan to explore more advanced techniques such as hashtag dictionaries to use in our machine learning models. And that will be all for my presentation. Thank you for paying attention.